with this kind. This is not Photoshop color. Okay, this is real. This is a very nice landscape of another crater caldera, active, with a lot of CO2 coming out here. You cannot even stand there, so much CO2 is coming there, and I know it because I didn't swim there. I mean, you can walk and see the bubbles. It's because also there we made some videos of sublaguna activity, and people who swim there, they got almost dizzy and so much CO2 comes out there. Due to the volcanic crash of 2006, we have left this volcano out for our CO2 and SO2 and whatever measurements. So we haven't done this. We are going to do this either this year or next year with Spanish people I work with. We publish about Pululawa, it's another volcano I'm going to show you in a second, and Curicocha, a study which we published already in last, maybe 2007, I remember. This is the same volcano from above. As you can see, it's very light. It means it's very acidic. We talk about almost rhyolitic in composition. That means 65% and higher SiO2. This is a nice volcano. This is close here to Quito, very close. It's the northern part of Quito. It's the second most dangerous volcano of Ecuador, and has been very active 400 before Christ. And these are domes. These are huge domes, and this is a huge caldera, which you can see from above. These are the domes. This is a caldera, but it's only 3 to 4 kilometers towards it. What I told you before, the 15 to 20, it's a big difference. And some people tell me, but people are living inside. I said, yeah, there's a. You know, I don't remember in the States what kind of minority you take to make jokes about. Here they take some people from the southern part of Colombia and say, you know, immigrants from Pasto. Because they do all the wrong things you can do, you know. But we make always jokes about this. But people are not aware about this. We made a study about this. This is also published, about the CO2 all around here, diffused degassing in the soil. And it's a lot, very high contents. Okay. What we're going to do today, I'm going to talk a little bit more about Cotopaxi. We have prepared about this too. We're going to get down here from the platform of Quito, down here this way, go this way, and go here through, and go up here. Okay. This is Chalupas volcano. This is Quilindanya, Cotopaxi. This is Sincholagua, Rumiñahui, Pasochoa, Ilalo. This is Antisana, and there are another 30 volcanoes here, very small monogenetic ones. This is the volcanic complex of Pichincha. This is Atacazo in Iñahuilca. Iñahuilca is active. This is Corazon, that means heart. And here we have a double peak of Ilinizas, and here the 3 widows. So this we're going to see all today. But we should hurry. Everything is based on how dangerous a volcano is on the Volcanic Explosive Index. You can read this. It's in Spanish and English.
What is it? Volcanic Explosive Index? How high does it go?
Okay. It's like the Richter scale for volcanoes, and it's based on the volume of material expulsed by one eruption. Okay, so you start with a few cubic meters and get up to a few cubic kilometers, and every number is 10 times one number higher than the other. 10 times more material have been expulsed. Now, if you take a volcano like Mauna Loa or Kilauea, for example, then it's going to be a 0, because very low material which is get expulsed by every pulse of the volcano. If you take a volcano like Stromboli, which is expulsing every day a lot of material, which is the most active volcano in the world, it's not that much. It's something more than Kilauea. Then you got it 1. And when you got an explosion which killed, I put here, of course, volcanoes here from Ecuador, so people have a meaning to that. So Pululawa, which I recently have shown, is a 6. A 6 has been, for example, the second biggest explosion of the last century, Pinatubo, in the Philippines. It was 6.0. Pululawa was a 6.2. So, in 6.0 of Pinatubo was responsible for cooling of the Earth's atmosphere of 1.5 degrees the year later.
I'm trying to relate it in my mind. What was Rainier?
Rainier can be a 5. A 5 was Mount St. Helens.
I'm sorry, Mount St. Helens.
Mount St. Helens was a 5. Rainier can be also 5. So we talk about Tuesday. Of course, the only volcano in the world which has an 8 is Yellowstone. And Chalupas is a 7, so 10 times less, or a 10th. So Yellowstone is the only active volcano which can have an 8. 30 million people are going to die instantly by an explosion of Yellowstone.
Why could that be an 8?
Because the material expulsed by only one eruption is much more. It's that much or more.
Inverted.
More than 1,000 cubic kilometers.
When Yellowstone explodes, it'll extend all the way to Denver.
It's
I guess because of the size of it.
Yes.
Okay.
Yes.
Okay.
And because of the magma chamber, because of the chemistry, which is very acidic, because of the water-magma interaction and things like this. There are many factors. But once again, the most dangerous volcano in the world is Yellowstone. And the only one which has an 8 is Yellowstone. There are a few 7s, many 6, and many 5s and so on. But Chalupas, here is an S missing, this is a 7. It's the most dangerous volcano here of the region. We're going to see it today. So Cotopaxi. Cotopaxi is a very nice volcano. As I said, very active too. About the statistics a little bit. This is the volcanoes we're going to see. This is Sahad, Corazon, and Ilinizas, the double peak. There's almost no glacier anymore there. There's almost everything gone.
Is that from global warming, or why is it
mainly,
from
mainly.
Yeah.
This Pasochoa, as you can see, like Yellowstone, it has a collapsed area. Okay, most of the volcanoes here have this. Sinchylago we're going to see also, I guess, also on the side. And this is a little bit the eruptive events of historic time. And before that, we have in fact 19 big events in the last 2,200 years. We have even historic drawings about this. About this I told you already. This is towards us, towards the north. This is the northern basin, as we say. This is Cotopaxi, and here the volcanoes towards the north. And this is how the Lhasa, the volcanic magmas, are going to behave. They're going to get together, and if we have more than 25 million cubic meters, then it's going to get into the rivers, in 2 of them, or natural drainages, as you want to call it, like this. They're going to get like this, and this is a city, as I was telling you, which is going to be hit in 30 minutes. These are the actual houses and the blocks and everything, and this is only reconstructing the last event, which was in the 26th of June, yesterday, in 1877.
What about the one in 1942? Was that not?
It was just explosions, nothing else, no Lajas.
Yeah.
We talk about big events in Lajas.
In that map, where is the shopping mall?
The shopping mall is exactly here.
okay.
We should drive through there, in fact,
Yeah.
and see things like this. Or on the way back. On the way back, I think it's better. Do you have an idea of what we are talking about? This is an actual picture. This too, on the side of these rivers, and this too. Now, of this we made a modelization. Okay, we took this, here it is, and look now, a normal Laha. There are 3 different scenarios: the frequent, the moderate, and the strong one. We're talking now about the frequent, the smallest one. Okay, this is the Laha where it's get to.
Wow.
Now, everybody will say, in a pessimistic way, everybody's going to die. No, I say no. Some birds are going to survive. That's it.
Some birds.
This is for the north. This is for the south. To the south, it has a big extension. Also to the city of Latacunga. Here's a volcano. This is a textile factory, which was covered by Laha, and now it's a symbol of the last destruction there. And people on the side, even below that, have built bridges and hospitals and houses and whatever, and schools. They simply didn't get it. And about this we can talk also a lot, but you may see this. We filmed this also in the documentary I have here for you. So you may pass them through, just go anywhere, and we'll give you already some. This is to the south. This is the infrastructure. So this is hopeless to survive. And people, once again, they don't get it. Now we have a government now where the president is a friend of mine, ex-colleague of mine, and I hope I have 10 here. I just took some. 2, 3, 4, 5, 6, 7. The rest I'm going to give you on the way back, okay? It's in Spanish, but still. So things like this are going to happen. And to the east as well. The most important infrastructure in the east, in the Amazonian lowland, are bridges. And they are also hopeless to survive. And these communities as well. So this is going to happen, I told you. And this from Mountain Talents. And it's going to cover the whole country with ash. And for some weeks and months, we are not going to be able to use the airports. And people think, no, the lava is not going to melt that much. In fact, it's true. It's more likely the pyroclastic flows. Something else which can happen is, of course, a lateral explosion. Here, taking the model of Mount St. Helens for Cotopaxi. And this is a picture of Mount St. Helens. And this happened twice before. We have had lateral collapses of Cotopaxi twice before. In 4,600 years ago and 2,200 years ago. 2,300 years ago. And here's my university, exactly here. So something has to be done. Pyroclastic flows, like in 2006 in Tungurahua, are also very common. We're going to see some today. And this area of Tungurahua have been covered completely by pyroclastic flows, and 6 people died. And this is a picture I took in 98 or 99. Here's my wife. And these are birds, these are symbols, and the entrance of the city of Banyos, which are the foothill of there. And this is after the pyroclastic flow. And these are the minor pyroclastic flows. There are other areas with much more. And these pyroclastic flows can provoke, of course, in the case of Cotopaxi, lahars. This is a picture from the USGS, from Armero, from the city which was covered by the lahars of Nevado del Ruiz in 1985, after warnings. And this, you know, this is the city of Armero. 25,000 people died. This was a bank. And Cotopaxi, well, it's active. You can see here the fumaroles. Here also. We have even phreatic explosions since the reactivation by the end of 2001 until today. Here's the phreatic explosion. And the ashes will be distributed towards the west and southwest mainly. And we can do many things about this.